Hello and welcome to LuckyMath. In this video I'm going to show you how you can graph exponential functions, and I'm not going to do this by plotting point per point and then connecting these to a graph. You can do this by yourself. What I want to show you is the big picture of how exponential functions look like. So the exponential functions are the following. F of x is equal to a to the power x, where the base a can be any real value which is greater than 0 and not equal to 1, and the argument x can be any real value. So if this right here were to be the y-axis, f of x, then this line would have to be the x-axis. And for an example, let me graph the function 2 to the power x. So where a equals 2. Then this would look approximately like this. So this would be 2 to the power x. And this function will cross the y-axis at the value 1. And this is a condition for all exponential functions. So all these exponential functions will cross the y-axis at the value 1. Why? Because if you set the argument x equal to 0, then this will be the same as a to the power 0, and this will just equal 1 for any base a. So what you notice when you look at this function is that it will rise very quickly, but it then also flattens and it will approach the x-axis. And it is important to note that it approaches the x-axis, but it will never cross it. So all values on the x-axis will get mapped to a positive value on the y-axis, and none of these values get mapped to either 0 or a negative value. So 2 to the power x is always greater than 0. Now let me graph, for example, 3 to the power x. And this function would look approximately like this. So this would be 3 to the power x. And again, this function rises, and it will rise faster than 2 to the power x because the base is greater than this base. So the greater the base, or the larger, so if I would graph 4 to the power x, it would be even steeper. So this function rises, but it will then also flatten, and it flattens even quicker and will again approach the x-axis, but it will never cross it. So this function as well is always greater than 0, and this holds for all exponential functions. None of the exponential functions will map to either 0 or to a negative value. Now let's try to graph 1/2 to the power x. So far, these were bases where a was greater than 1. Now let's try to graph this function where the base a is less than 1. So for example, 1/2. And all we need to do is mirror 2 to the power x at this particular line, the y-axis. So what we get is approximately this function right here, which again crosses the y-axis at the value 1, and this would be 1/2 to the power x. Now if you would like to graph 1/3 to the power x, you look at 3 to the power x, and you again mirror this function at the y-axis, and what we get is this function. So this would be 1/3 to the power x. And then if you had 4 to the power x, you can also graph 1/4 to the power x. And I think that you get it. So this is how you graph fractions where the base is less than 1. Now one last thing that I would like to show you is what if a equals 1? So why do we exclude this value 1? And if, let's say, a is equal to 1, then this would just be f of x, which equals 1 to the power x, and 1 to the power x is just 1 for all exponents x. So this function would just look like this. And this is a constant function, and you can see that this won't rise exponentially nor decay exponentially, and therefore this is not an exponential function. Thanks for watching, rate the video, subscribe, and see you soon again when I say welcome to Lucky Math.